Hey guys, welcome to a new video, and maybe you can still hear it, maybe not. I'm still recovering from getting the Rona. I managed to avoid it for 3 years, but then I still got it. I got pretty sick, but I am getting better, but I'm not yet feeling all too great, so I'm going to try and kick off a video kind of, live stream style without a script and everything else. And, well, see how that goes. It will be a fully edited video. This isn't a live stream. But, yeah. Today, I wanted to talk about all the connections, like the wire ferrules, or... so, just as an example, these are wire ferrules, or what type of wires you can use on the QuinLED-Dig boards. So, if you're looking to hook one up, well, watch this video, and you'll learn a lot about how to do that, and which wire sizes you can use, and things like that. Okay, well, let's have a look. Starting off is a guy that's been half introduced and half not, and that is the Dig-to-Go. And the Dig-to-Go is a new product in my lineup. It's a bit less DIY since it comes nicely assembled in this little case here. The website is already live, and we've already done a pre-launch on the Discord server. And the video about the real launch of this guy, including bundles and everything you need, will be really soon. But it's taking a while. But yeah, anyway, this is a Dig-to-Go. And, well, this is definitely by far the simplest thing ever. You get a little pigtail wire with it, which has a white plug here and a JST plug that's also on your LED strips here. You plug it in, it only goes in one way, it clicks in nicely, and then you take your LED strip. This is just normal 5V WS2812B. You connect that to the black end. Again, it goes only one way. There's a little notch there. And then you take your USB-C cable over here. That's plugged into a 5V 3 amp, or at least USB charger. And you plug it in over here. And there's a little green light here. It turns on. And that turns the strip on, and you're done. Let's see if the button works. Button works. So yeah, and then you can do the regular WLED thing, like joining the wireless network and connecting it to your own network and using the app and setting all the settings, and yeah. So that's a Dig-to-Go. Perfect for smaller installations, or even up to 300 LEDs if you don't need full RGB white output power. And yeah, moving on. Well, next in the lineup is the guy we all know. It's the Dig-Uno. This is a slightly older model. This is a V3, not a V3.1, which we're currently at. But I'll highlight those changes on the Dig-Quad because they're basically the same between the two boards. So you get your Dig-Uno, and you can take this ESP off. You kind of wiggle it off like that. When you receive it in the box, there might be a blind plate here on the exposed row of pins. That's basically just to protect from shipping damage and stuff like that. But you don't really need it for any functionality or things like that. So you take it off, and that reveals 4 screw terminals on this side and 2 on this side. Now these are normal type screw terminals. They're not raising clamp, as we'll see on some other boards. But that's also partly due to cost. You have a plus on this side and a minus on this side. You can see the plus very clearly here for the power input. Dig-Uno takes 5V to 24V. You just match the voltage your LEDs are. And then on the other side, let me get a screwdriver real quick, is we have a plus out, as you can see here. That's this screw here. We have LED 1 and LED 2. That's these two. And then we have a ground out. And, of course, there's a fuse and level shifters and all kinds of things going on in the back. You don't have to worry about that. If you just want to drive your LEDs, that's how it works. Now, for these type of connections, I recommend... let's first talk about what sizes of wire you can get in there. Well, this goes up to 16 gauge with a wire ferrule. you'll ask, what is a wire ferrule? Well, if you're working with this type of cable, these edges, or these little dots here, actually have a little bit of solder on them, but basically they're, let me just cut this like that, and then let me strip it like that. Oh, no, tried to do them all at the same time, didn't work. There, these are stranded wires, and once you start using, well, any type of wire really, you'll quickly notice that getting stranded wire into a wire terminal, well, it's a real bother. So if I remove these little caps here, you'll see that this is actually lots of tiny little wires. So if you try and jam that in your screw terminal, try and jam that in your screw terminal, you're not going to have a great time. That's why they invented wire ferrules. That's basically these orange little things here you put on the connections, and instead of having a stranded connection, you now have a solid connection. So let's do that real quick. We already stripped this one. Just as mentioned, all tools will be listed in the video description and in the linked articles. I have a complete tools and equipment article where you can find links to everything I use here. Today, for instance, one of the lifesavers, if you do a lot of this, is one of these automatic wire strippers. It's going to save you fingernails and teeth and everything like that. And the other thing you need for this is you get a little box like this. In this case, we need the thinnest version, but we'll take a look at 16 gauge too, because there's a little trick. We're going to take 3 of those tiny little ones. As you could see, I was already twisting the wires. I do that because then it's just easier to get into the wire ferrule, like so. You can also do it if it's not twisted, but I just like doing this better. There will probably be a discussion in the comments that you shouldn't twist the wires. I think it's generally okay, but yeah. So you take your ferrule crimper here, and you put the ferrule in like so, and then you just give it a squeeze, and then the ferrule is crimped on. There we go. And now we have 3 good, strong connections, and you can see there's just a little bit of the wire peeking out here. That's basically the ideal crimp. And if we now wire this up, we have the plus terminal here, so that's where red goes. Then we have the green one, that's for LED 1. There we go. And it's not in yet. Well, this immediately comes to a trick I wanted to show you. One of these things with these terminals is sometimes those ferrules don't like to go in that well. Well, there's a little trick, and that's also how you get 16 gauge wire to fit. And that is, if you take a plier like this, and you just give a little squeeze after you've crimped them. There we go. That basically forms the ferrule better to the type of screw terminal we're using. And if you now try to insert these, not sure I opened these terminals right. Anyway, let me try these real quick. There we go. Those go in a lot easier. So let's screw those down real quick. Don't have to go super tight, but decently tight is good. You also don't want them coming out. And there you go. This is just a little pigtail wire because it's just easy to connect the LED strip to it after that. Yes, this is a lot thinner cable than you could connect to a Dig-Uno, like that. So you have a little pigtail, so it's easy to connect and disconnect. But in the end, a single edge injection like this will only give about 4 amps you can input to the strip. You'll have to split it to multiple wires and then inject along the strip to get more power into that LED strip. But this video isn't about that. I'll have articles linked in for that in the description. There's a power injection live stream and also a live stream test we did, how much current you can actually get into an LED strip from a single edge connection. Right, I mentioned 16 gauge, so let's do that too. We've now zoomed in, and as you can see, this is officially 16 gauge wire, and this is high quality silicone wire. And well, we're going to do the same thing. I'm going to use a little trick. If you want to separate this silicone wire without it splitting incorrectly, I basically always use a pair of scissors, and you can easily cut it apart like that. And that way you know you're not going to have any tears in between the wires, because that can easily happen with this type of wire. Okay, we're going to strip that again. Magic of the automatic wire stripper here is that, well, it's just always correct. And I'm going to give those a few twists again. As you can see, this is a lot more copper, but if you want to have power in and then power out of the board, and then it's fuse protected, but then we want to split it like using a Wago block or something like that, well, you want to have the largest diameter wire in there that you can. So I believe for these I can use the yellow plugs, I think. Let me try that. Well, tight fit, but it fits. There we go. Actually, I think this is, yeah, that's too tight a fit. If you see it curling up like that, it's too tight of a fit. So we'll go one size bigger, and that is these black versions. Nope. Yeah, that's better. See, you have it poking out again. You can either keep it poked out or you can cut it off after you've crimped the ferrule, and you'll have a great connection there. So let's crimp these again. The ferrule crimper also auto adjusts the size. I like to keep a little bit of pressure on it so I know the wire isn't slipping out. But now we have a little problem. If we now want to try and insert these wires into these terminals, if you use some force, and I don't know, you can kind of get it in, you kind of can't. It gets frustrating sometimes. So we take our little tool again and we do that little trick where we flatten them basically. And then you'll see that they easily slide in, no problem whatsoever. Oh, that's the wrong screwdriver. So that's also what I recommend. You can use a maximum of 16 gauge on a Dig-Uno, or, and we'll look at that board next, on a Dig-Quad. And then if we quickly take it, I'm talking about these terminals here, because they're the same terminals. But as you can see here, 16 gauge is in there. It's definitely secure. It's well connected, and you can do that on the input and the output. And especially if you're going to run more than 5 amps or something like that, you basically take a 16 gauge in, you take a 16 gauge out, and then a Wago, and you split it into multiple cables for doing multiple injections. If you, for instance, want to run 10 meters of this 5-volt LED strip, you kind of want a front, middle, and end, and well, a Dig-Uno can handle that perfectly. Right, so let's disconnect that, because we're going to move to a Dig-Quad. But yeah, the squishing trick, and maybe some electricians in the comments will scold me for it. I don't know. I don't think it does anything bad to the integrity of the connection. I actually think it makes it better, because it forms it better towards the size of or the shape of the terminal. But yeah, that helps a lot with getting those wires in there. Okay, so we're going to replace this Dig-Uno with, oh, didn't show you. Once you have everything connected, you basically place the ESP32 board back on top, but be mindful that you line up the pins correctly and that the USB port is on the fuse side. That's important. If you don't do so, it might break. So yeah. Okay, so Dig-Quad time. A Dig-Quad is basically a Dig-Uno, but then it has more channels and more power distribution and well, not really more features except that. So instead of 2 data channels, the LED 1 and LED 2 here, we get 4 data channels, and instead of just 1 positive output and 1 negative output, I just mentioned that you can split using a Wago. And while that's okay and valid, especially if you're staying at like 10 amps or something like that, once you start using more current, and the Dig-Quad supports 30 amps, and multiple LED strips and various other things, fusing becomes more and more important. And you kind of want to fuse each injection line instead of having one giant fuse and then a bunch of cable. Well, if there's a smaller size cable there, the big fuse won't protect that. So the Dig-Quad adds power distribution to these 7 positive and 7 negative terminals, and it has 5 fuses. As note, output 1 and 2 share this fuse, output 3 and 4 share this fuse, and then 5, 6, and 7 are this fuse, and this fuse. You're allowed to use 10 amps per fuse output and or port, whichever comes first. So these 2 ports can share the 10 amps of this fuse, while this one would be outputting it directly. And once we're done with the Dig-Quad, I'll actually show you a trick how you can use bigger wire sizes than 16 gauge. Because again, just like for the Dig-Uno, these are the exact same terminals. Did I not open this one? No. Okay. So it fits the exact same wire size with the squishing trick. So you can have 16 gauge coming out of the board. But as I said, in a minute, we'll take a look at a little trick how you can get even the bigger sizes from a Dig-Quad. Or you can step up to the Dig-Octa, but we'll look at that in a minute. Right, so output-wise, I just showed you how to crimp this and how to squish it, and then you can use that. But as you can see here, these giant input terminals are something different. They're called barrier-style terminals, and I have a specific article which talks about these terminals which are on my Dig-Quad and my Dig-Octa system, and how you can wire cables to that, etc., and what to get, and because you need some different tools for that. For these, you need wire ferrules, but for this type of terminal, I like using forks. So let's, I'll get some cable, and let's crimp a fork style on there, because especially if you're running a Dig-Quad, you're likely also using a frame style power supply. So let me get that real quick. So that barrier terminal is there because it fits, or it accepts larger diameter cable, but still works with these ferrule based cable. So if you wanted to hook this up, let me get a bigger screwdriver here, you can open these up enough. And again, the squishing trick also kind of works on these, so that you can actually just screw these down like so. And that gives a good and secure connection. But that's the 16 gauge we just worked with. If you want to really run 30 amps through this thing, and again, I have a video about that here, about what is actually needed to do that, you want to step up the wire diameter for your input wires. So this is 16 gauge. This is 12 gauge. And as you can see, that is a lot more copper there. So yeah, and you can hook up to 2 of these 12 gauges to the Dig-Quad to provide it with the power it needs. Especially if you're running 5 volt, 2 of these 12 gauges, if you're really going to run 30 amps out of here, isn't an exaggeration. Again, look at that video. I've linked it in the description. But it really needs that to prevent voltage drop even just coming into the board. So basically, if you have a lot of copper going out of it to do all your power injections and things like that, you also need to make sure it goes into it. Now, one of the reasons for choosing one of these barrier connections is if you take a look at a Meanwell power supply, and this is a LRS 600-5, it also has these same type of barrier terminals. It's just because they make for a really nice and good connection. So instead of using a wire ferrule for that, we're going to use a crimp style, fork crimp style connector for that. And I have 2 sizes here, and I might have mixed them up, not sure. Well, they're almost the same. Let me show you the baggie real quick. So this is the baggie. It says SV, SV stands for that, well, this fork style terminal. 5.5, that's the millimeter square diameter of cable it accepts, and it's kind of a range because you crimp it, and this will accept 12 to 10 gauge or something like that. And then it says 4, and the 4 is important in this case because this is an M4 screw terminal, and Meanwell also uses M4 type screw terminals. So if I undo this terminal here, you can see that this is the 5.5 minus 4, fits in perfectly, and well, as I said, that gives a great connection. Now you can use a bigger size if you want to. Shouldn't, but you can if that's the only thing you have. This is a SV 5.5-5, so it thinks it's for a bigger connection, and well, it barely fits here, but I think we're going to have an issue actually. Oh, okay, it still fits on there too. So you can use an SV 5.5-5, or as I recommend, a -4, because that's what it's actually made for. So then you can use these 12 gauge or even 10 gauge between your Meanwell power supply and your Dig-Quad and get a perfect connection that can handle a lot of current. And as I said, you can use 2 because these 2 are both positive and these 2 are both negative. So you can go up to 2 times 10 gauge to go into this terminal. Now, I want to show you the crimping process real quick because we're going to use a different tool for that. And that is this guy. It has a color-coded here, but more importantly, it's for a range of wires. Red is the smallest, blue is the middle, and yellow is the biggest. In this case, we're going to use the biggest. And let me try and find those 4. Yeah, so this is 5.5 minus 5. This is 2. Okay, I'm going to snip this off because I'll strip a new part of it. There we go. We take our trusty wire strippers again, and we strip off a little bit less because we don't need as much as we do with a ferrule. There we go. Even big wires just snips it right off. Perfect clean cut every time. Yes, I'm twisting it again. And what I like to do for this is I open the crimper and I put the crimp inside of it, and I line up the back so that the last bit of the part that's crimping down is basically on the metal, and I give it 1 tick so I know that it's basically locked in. And then in there you have a metal cylinder. Not sure you can see it, probably. You need to try and get the wire perfectly in there. And there you go. And you see a little bit of the wire poking out right there. And then you crimp it down and you see it nicely squished. And if you want to be really sure, you move it up a little bit, and you give it another crimp, and then you know this is securely attached. That's not coming off. And then there's a nice crimp. So let's do that again. You take your fork style crimp. You basically load it into the crimper and line it up just so that it's at the edge there. Give it 1 tick. I like making sure that they're both oriented the same way. Yep, I see it poking through, and I crimp it down. And just to be sure, let's do a second one. There we go. Oh. And now we have a perfect crimp for our connections here. So positive is always on the side of the fuses, and negative is, well, on the other side. And as you can see, this slides in perfectly. And you can torque that down a little bit. There we go. And, well, you can close the caps, I don't know. And, well, you basically do the exact same on the power supply side, and then you have the perfect high current connection for up to, well, this is up to 10 gauge. In theory, you could go even bigger, but generally for everything we do with the dig boards, 10 gauge is really the maximum. Now, one quick highlight I mentioned, this is a version 3.1 board instead of a 3.0 board as for the Dig-Uno. And I was going to point out a difference, and that also has to do with cables. Because you see this little your little dip switch here, and the 3.1 also has that over here. Those are dip switches for the resistor switcher function. So if you're running 2-wire power plus single data, you want to put it back on the original option you received the board in. You just flick them like so. Try not to, you know, scoot over the board with your screwdriver. So you put them in the 249 mode. And if you're running 3-wire cable like X-Connect or something like that, where ground and data is bundled, so even 2-wire cable with ground and data running right next to each other, like, you know, just normal cable where it's attached like that, you want to flip that specific channel into 33R mode, which is optimized for that type of cable. And I've shown in live streams again, the anniversary live stream for the release live stream for the Dig-Octa, I believe, you can get up to 60 meters in lab conditions. In real life, it'll be less than that, but yeah. Now, a little trick, and this works on the Dig-Octa, the Dig-Quad and the Dig-Octa, or at least the Power-7 and Power-7HC, which we'll look at after this. If, for some reason, especially if you're running 5 volt, you need a larger diameter cable than 16 gauge. Not because of the current, but because it needs to travel a long way, you need to minimize voltage drop, and 16 gauge just isn't going to cut it. What you can do is, especially on the shared fuses here, so output remains 10 amp, is you can insert this fork terminal into these screw terminals. Screw them both down. You also have to tighten both of them. There. And now you have a very good connection there between these two screw terminals. And you can run, well, this is now a 12 gauge cable, but the crimp here would accept up to 10 gauge. So you can run a lot larger diameter cable. Yes, you'll use 2 of the screw terminals. In a sense, you only have 5 fuses anyway. Still, if you have a 10 amp fuse in here, you could use 1 for an edge connection, 2 for an edge connection, and 3 and 4. And then these would be middle connections, because those could also have 10 amp fuses, and etc. You're allowed to put 5 times 10 amp fuses in here, as long as your continuous current doesn't exceed 30 amps. It's a recommendation. It's not going to explode if you do. And peak, it's perfectly fine. It's just, I test these boards and I rate them for a certain current, and if you run more current through them, they'll just heat up a little bit more. Anyway, if you need to run larger diameter cables and you don't want to go Dig-Octa, well, you can do it like that. So that's a neat little trick, and that works quite well. And again, it's the SV 5.5 -4, and I'll link to my article in the description that explains how to get the correct fork for the type of wire you're using. And the -4 is for, well, this type of terminal, or if you want to double up, I call it the double up feature for these type of terminals too. Right, let's move on to the Dig-Octa. While digging for the Dig-Octa, and the first thing we're going to look at is a brainboard. I actually found a version 3.1 of the Dig-Uno. As I mentioned, it's just the resistor switcher over there, and there's not too many other changes. Right, so Dig-Octa, we're only going to talk cable connections, and that's very easy. This is Ethernet, this is USB-C, not much to explain there. And all of the others are pluggable style 3.81 millimeter screw terminals. Now these are a bit higher quality terminals because, well, they're also more expensive and it's a more expensive product. But these are all rising clamp. And although officially these are smaller terminals than basically the ones on the Dig-Uno and Dig-Quad, I think even if we take our 16 gauge wire here that we have, with a little bit of finesse, there we go, we can actually get those in there. And as you can see, if you get too many of those, it's probably not going to fit perfectly, but even 16 gauge will still go into these 3.81 millimeter pluggable. Pluggable means you can disconnect them like that and connect them again, style terminals. So again, you use wire ferrules with the size of wire you have. I mean, it doesn't matter if it's this size or that size. No, this is not how you connect this. This is just to show that any size of ferrule will go in there. So I recommend using ferrules. 16 gauge is a bit big for just data wires. Just for a very quick reminder, we have 8 data channels here. We again have also 8 resistor dip switches here. Then we have 2 button inputs. We have a I2C bus, so you can attach other things. We have the relay terminal here, and we have the power input terminal here. It can also receive power through its stacking posts and USB, and that means you can connect all of those 3 at the same time, even with different voltages. That's all fine and supported. So for instance, we could have this PUE splitter here, which inputs 12 volt into this connection, but then you have a power board using the a power pole feature, and those can come in through the stacking connector, and maybe you still want to connect USB-C. All good. Right, moving on from the Brainboard, we're going to the Power-5. Okay, we have a Power-5 here. Power-5 is basically a combination and one new thing. We have the burial style input terminals again. It's still M4, so you use the same style forks. Let me just demonstrate that real quick. There we go. Negative on this side, positive on this side, and well, it's the same type of terminal. There's just 3 instead of 2. They're not to connect multiple power supplies. Also goes for the Dig-Quad. You're not allowed to connect multiple power supplies to one board. They are for power supplies that have multiple outputs. So here we have 3 positive outputs and we have 3 negative outputs. And especially with this 5 volt version, having enough copper there, because this board, this is a normal version board, will do up to 50 amps. You're going to want lots of those connections to your power supply to not have too much voltage drop from the power supply to the board. It's important to remember. So these fit here. In theory, I guess they'd also fit here, but don't do that, because that doesn't work on this board, because this board has plus and minus on the same plug. So these are 5.08 millimeter style pluggable connections. So they're a bit bigger than those on the Brainboard to handle more power. The Brainboard doesn't do power. And in here, the 16 gauge should fit just fine. Let me make sure this is opened up. I also try to make sure that all the screws will always be Phillips head. And so in here we have plus on this side and negative on the other side. Let me just reinsert it into the board. And this is 16 gauge, which should go in easily. There we go. And this will accept 14 gauge with a wire ferrule. But that's it. No tricks or anything else to make it accept bigger wires. Then again, you have 12 output connections. So even with 14 gauge wire, you can certainly get up to that 50 amps. Okay, let's quickly move on, because there's not too much others to say about wiring for these power boards, to the Power-7. So Power-7 is a slightly different design. Oh, I'm missing some fuses here. Well, I'll probably use the board. It still has the normal version still has the 3 barrier input style terminals for the forks, so you can easily connect up to 3 times 10 gauge or 5.2 millimeter square. Plenty of copper there, especially if you use 3 of them. You kind of have to if you want to get up to that 50 amp, because you're only allowed to do about 20 amps per terminal. So if you want to do 50, you need 3 wires. But it's also explained there on the silk screen. Anyway, this uses screw terminals instead of pluggable terminals. Downside is the pluggable terminals are very nice if you're building a stack, so you can reach each plug and screw in the wire and then just plug it in. The For the screw terminal variant, that's a bit harder because, well, if it's stacked on top, you can't really reach those screws anymore unless you use a special tool. But anyway, these are 7.62 millimeter terminals, so they'll again easily fit the 16 gauge wire ferrule here. I mean, look at that. And they will fit up to 10 gauge without a ferrule. But since these are barrier style terminals, that's less of an issue than, for instance, on the Dig-Quad we looked at, because we can't really squish our wire into there. So let's take a look at this 12 gauge, and then we'll also put some some ferrules on there. So this is the 12 gauge, and in theory, let's twist it up a little bit. There, also on this side. And we should be able to get that into this terminal fairly easily. I still like using ferrules, but yeah, okay. I stripped them a little bit too long. I stripped them for using ferrules. But as you can see, this goes in. There's no real hairs or strands there. And yeah, you can use these with bare wire. But I'm a ferrule guy. Is that a thing? I don't know if that's a thing. But I'm going to use ferrules. So 12 gauge with ferrule should fit. So let's get some of the biggest ferrules here. And the tool, well, we already stripped them. Oh, I messed it up going into the ferrule. Oh, did it again. I'm going to blame this on Corona. Okay, that's good enough. Let's do this side. Probably I kind of squished it when I screwed it in. Yeah, see, this one just went on easily. Right, so let's crimp that down real quick. There we go. And these should easily fit. Well, if I open it up. In here. Now this board works. What the? Wrong one. This board works differently than the Power-5, where the Power-5 has. Where did I put it? It's gone. Oh, it's buried on my desk. Where the Power-5 had plus and minus on the same plug, this has 16 positive and 16 negative outputs. So you put the positive wires over here, and you put the negative wires over here, and there you go, 12 gauge with a ferrule, no problem. But, as I mentioned before, there is actually a little trick, and that trick, which we used on the Dig-Quad, also works. There we go. Also works on the Power-7 and the Power-7HC, which I'll show you in a minute. Let me try and find the snipped off end with the forks. There. This is the SV 5.5-4 crimp on there. And what you can do is the same as on the Dig-Quad. You can use two terminals. Well, let me show you on the positive side. Do I have the positive? There. This should be it. You can use two terminals screwed in there, and then you can use a bigger wire size than you can fit in here, so 12 gauge with a ferrule, or 10 gauge 5.2 millimeter square, I believe, without it. But then you can use two, so if you get the right size fork for like an 8 gauge cable, if you ever need that, you can run up to 20 amps through that single cable. So if you're doing, for instance, bus bar style cables, you could use this for that. This is a good connection. This is the 5.5-4. The -5 should also work well for that. And yeah, so the double up trick also works on the Power-7. And then the last thing we're going to look at is the behemoth, and that is the Power-7HC. So this is a normal version. It supports up to 50 amps. Connect all 3 input wires because you're allowed to do 20 amp per wire and then 50 amp in total. But if you need more, it's the bigger sibling here. It's basically the same design. You again have 16 positive outputs and 16 negative outputs, but now you have a different input stage, which means you can use up to 100 amps continuous. Quick note about that. Why do I use 5 amp and 10 amp fuses a lot? The reason is this. If you have an LED strip, 5 volt, 12 volt, 24 volt, it doesn't really matter. Because of the amount of copper on there, a edge injection, so at the edge of an LED strip, won't take up more than 4 amps maximum. It just won't allow more current in, because then voltage drop, it doesn't allow it to raise the current. A middle injection, so where 2 strips meet and you have copper going both ways, will take about 8 amps. So 4 amps I like to fuse with 5 amps, and 8 amps I like to fuse with 10 amps. So put your edge connections on all of the 5 amp fuses, and put your middle connections on the 10 amp fuses. That's basically the idea. And the idea they come staggered in the board like this is to spread out the heat. If you'd put all the 10 amps over here and then all the 5 amps over here, this area would see a lot more current, and it's better to divide it to divide the heat basically. Anyway, that's what the Power-7HC is for. This board has multiple layers, lots of copper, and it can handle the load basically without getting too warm. So that's why it gets all 10 amp fuses, so you don't really have to worry about that anymore. That's also why you don't need a bigger fuse than 10 amp, because a middle injection, well, there's only one exception I know of. It just won't go above 8 amps or so. Right, so input stage is different. Here it's 3 times 20 amps. Here it's 2 times 60 amps fuse. Well, this is 25 amp fuses, but still. You can't really use these ferrules here. You couldn't really use these ferrules on the Barrio style M4 terminals anymore. That's why we use the fork style terminals here. Oh, you can't really see that. The fork style terminals here, because squishing this thing down, that's just not great. The forks are much better for that. Over here, we can still use our fork styles, but where this is M4, this is M5 with a mega fuse. So if we take a look at that, it comes with a screw, a compression washer, and then a normal washer, so it stays put. And basically what you do is you have this little lug here, you put the fuse on there, then you take your fork or your ring or your lug or whatever you're using. You can use 6 gauge or whatever is 4 gauge cable on here, as long as you get the right lug with an M5 hole. But this is the 5.5 minus 4, and you'll see this doesn't fit. And I think I should have the... No, I don't. Do I have a dash 5? I think I prepared one, but I don't know where I shot it when I cut it off. Yeah, oh, so this is a 5.5-5 fork terminal, or crimp. As you can see, then the screw fits just fine, where it doesn't with the 4. So, just to explain how that works. But there's a full article about that. So what you do is you take the lug, you put the fuse on there, then you put your ring lug, fork style, whatever, and you put the screw on there, and that means that the copper or the metal that the current is coming into is basically screwed directly against the fuse, which the current has to go through. The current doesn't really go into these posts, but you still need to have something to screw into. Of course, it does do so on the other side, but that's why I use these big posts, so we can actually transfer that huge amount of current into this board, up to 100 amps continuous. Spread over 2 6 or 8 gauge cables, of course. Right, my voice is clearly dying. I'm dying. But this was the last of the boards to talk about. From the tiny little Dig-to-Go here with plug and play functionality to a Dig-Uno with just a few simple terminals. If your project gets bigger and you need to do power injection, I highly recommend a Dig-Quad. And then if you want more quality of life and easier screw terminals and different styles like pluggable or these big terminals, you want to run lots of wires and have multiple brain boards and stack them on top, and whatever your situation requires, the Dig-Octa system should get you there. I hope that really helps explain what size wire you can use, how to use ferrules, how to use these fork style little crimp thingies, and get the right connections for the dig board you're wanting to use. For instance, no forks on the Dig-Uno because it doesn't support that, basically. Where the Dig-Quad and the Power-7 can be hacked, or for the input, these are great. So yeah, hope that helps, and thanks for watching. Let me know what you think in the comments, as always. So, see you guys next time. Bye-bye.